Hi everyone, this is going to be a short video lesson on how you can find the equation of a line using two different methods, which we'll get into. The main purpose of this video is to use whilst I'm away, but of course this can be used for revision purposes later on, as this is one of the trickier things in linear relationships for Year 9 5.3, so I figured what better time to make a video than for now. Before we get into it, hopefully you've had a look at this review question that's up on the board right now and had a quick think about it. So let's just quickly get into it. What is the gradient and the y-intercept of this line? Well, remember we're talking about y equals mx plus b. So we said that whatever's in front of the x is the gradient. So here the gradient is going to be 2. And then b is -4 in this case. So that means the y-intercept is going to be 0, -4. Remember, we want to add that 0 as well, because when we talk about the y-intercept, we want the complete coordinates, right? To say that the y-intercept is -4, people understand what you're saying, but the best thing to do is to write 0, 4, because those are the coordinates of that y-intercept. Anyway, this is a quick review to just quickly refresh your brain, and now going into the main substance of this video. So what we're talking about today, like I said, is finding the equation of a line, and it says using y equals mx plus b, and we are going to be starting off with that. That's kind of what we were doing just then, except now it's going to be in reverse. So I'm going to quickly talk about that, but then towards the end of this video, I'm going to talk about another way that you can do it as well, which uses a slightly more complicated formula, but it's a lot more flexible in how you can use it. Anyway, so let's focus on the y equals mx plus b method, or what we know as the gradient intercept form. So remember, we call it the gradient intercept because we have 2 points. We have 2 pieces of information. We have the gradient and the y-intercept. So if we know those 2 points, we've just found the line. So as we see here, if you know the gradient of a line, or you can easily find it, the question might not say the gradient is 2. It might give you 2 points, or it might give you a line, and you've got to find the gradient of it. And once you've found the gradient, along with the y-intercept, if you had the y-intercept, you just put that as a constant in your equation. So whatever the gradient was, you put it in front of the x, and whatever the y-intercept was, that's the constant after it. There you go. You've got your equation. So if we were to just do a quick example of that, so we want to determine the equation on the straight line shown here. So what we see here is we have our x-intercept being -2, and our y-intercept being -4. So what we want to do here is, if we can find the gradient and the y-intercept, we've got the equation of the line, because that's what we're trying to find. We're trying to find the equation of the line. So straight away, we know that because our y-intercept is -4, that means we have b equals -4. So that's half of the equation straight away. Now we just need to find the gradient. So if I started at that left point, remember we're always working from left to right. So if I started there, and I went down, if I ask myself how far down do I go, I'd say my rise is -4. Remember, it's -4 because I went downwards, and that's really important that you remember that. And that's what makes a gradient, which tells us that the line is going downwards. So here I started at 0 and I went down to -4, so the rise is -4. And once I'm there, I went from -2 to 0, so my run equals 2. Remember, run is always positive. It's the rise that tells you whether you're going up or down. So we have our rise is -4 and our run is 2. So therefore my gradient, m, equals rise over run, so -4 over 2, which equals -2. So now I have my gradient, I have my y-intercept. So therefore the equation, the answer to this problem that we have here, is y equals -2x minus 4. And that would be the answer. The question was asking us to find the equation in a straight line. That's what we did, because we were able to find the gradient fairly easily, and we were just basically told what the y-intercept was, so we just chucked it into the gradient intercept form. That's why it's called the gradient intercept form, because you need the gradient and you need the y-intercept. There you go. So that's fairly simple. So what I want to do now is talk about another method which is going to be a bit more flexible, like I said. We call that the point gradient formula, or form, or whatever. I'd say it's a formula because it is a formula. So this is useful if you don't know the y-intercept, but have a point and the gradient, hence the name. Right? We call it point gradient formula because we have a point and the gradient. It's not the gradient intercept. The main thing here is if we don't know the y-intercept, like we did in those previous questions, then it's going to be a lot more difficult because we don't have half of the information. So we're going to need something else here. So if you know any point that's on the line, say I told you 1, 2 was on the line, and I told you the gradient was 3. That's enough information for you to find the equation of the line, and it uses this formula that I'm going to write up now. It is y minus y1 equals m, and then in brackets x minus x1. So, a bit of an ugly formula there, but for those wondering, yes, this is also a red star formula, meaning it would be on your formula sheet if it was in a test. So what we see here is 3 big things. First of all, we see y1. So y1 is going to be the y-coordinate of any point that we're given. So when we're talking about being given a point, that point that we're given, we're going to call it x1, comma, y1. So we're going to take the y value of that point that we're given, and then we're also going to use a gradient that we were told. Oops, don't know where that come from. But we're going to get the gradient. Of course, if we're told what the gradient is, or we need to find the gradient, then there you go. And lastly, we're going to get that x coordinate as well, which I mentioned is the x coordinate of the point a second ago. And then we're just going to sub them into the formula. You could just leave it as that, but we will start to rearrange it a bit as well. We might as well put it into y equals mx plus b if we can. So it looks a bit ugly, it looks a bit weird. So let's do 2 examples now of how we can use this to solve a question. Alright, so let's start off with this. Find the equation of a line that has a gradient of 1 over 3 and passes through point 9, 2. So the reason why we want to use that previous formula, and I'll just write the formula off again really quickly. So we had y minus y1 equals mx minus x1, is because in this question we don't know what the y-intercept is. We know what the gradient is, but we don't know the y-intercept, so it doesn't help us. So y equals mx plus b will not work. So we're going to have to use something else. Straight away we know what m is. We have m equals 1 over 3. It just told us straight away. And now we're going to say that x1 equals 9 and y1 equals 2. They just come straight from the point. So we're going to be told, for this to work, we need to be told at least 1 point and the gradient, and then we're good to go. So we just, take that information from the question. There you go. And now we're going to substitute these numbers into this equation that we have, this formula. So we're going to do y minus 2. Because that 2 was what we found from the point, equals 1 over 3 x minus 9. Now, if you wanted to be a bit lazy, you could just leave it as z, because technically that is correct. But what I'm going to suggest you do is at least try to get rid of the gradient that's in front. Like we talked about in past when we talked about equations, we don't like fractions in our equations. So let's get rid of that 3 at least. So here we're multiplying by 1 over 3. So we could divide by 1 over 3, or we can just multiply everything by 3 across. So let's just get rid of this 3. So if I multiply everything by 3, so I would get 3y minus 6 equals 1x minus 9. And with that 1x minus 9, you might say, well, we don't even need the 1, or we could expand it. So let's just multiply that across. So I have 3y minus 6 equals x minus 9. And you could just leave it like that as well, or you could continue a bit further. And what we sometimes do is, rather than leaving it in y equals mx plus b, we could leave it in what we call a general form, where we move everything to one side, and then we just leave a 0 on the other side. So let's do that. So here we have 3y. So I'm going to take this over to the other side. So I've got a minus 3y. And I also have well, I might not do it all at once. So we have negative 6 equals x minus 3y minus 9. I like to put the x and y before the constant, but it doesn't really matter. And then now I've got to get rid of this negative 6. So I'm going to add 6, add 6. So I'm going to have 0 equals x minus 3y minus 3, because negative 9 plus 6 is negative 3. And that would be the answer. Now it doesn't really matter if you left it further up here. Like if you just left this as your answer, this would be totally fine. Everything else is me just doing a bit of simplifying. At least for year 9, that would be fine. Once you get into like year 11, year 12, we would be wanting to start using this. This would be a little bit better because this is what we call the general form. Not general because of general mathematics, general because it's a pretty common way that we represent our lines. Basically, the two ways we represent the equation of a line be y equals mx plus b, that gradient inset form that we were talking about the other day and today, and then also this general form where we have 0 equals something x plus or minus something y plus or minus a constant. There's your answer. We won't talk about that too much, but you can get to there if you want. I just want to do one other example of this. So say we had this. So in this question, we don't even have anything written. I mean, the question is saying find the equation of the line. So that's what it says. So find the equation. Okay? So again, we're not told what the y-intercept is. I mean, we can see it. We can see that the y-intercept is here, but we have no coordinates. Okay? And because we have no coordinates, we can't assume what it's going to be. So we're going to have to do something else. Again, we're going to need to find the gradient. And we have a point. We in fact have 2 points on this line. So let's use those 2 points as well, and then that will be sufficient. So first of all, let's find the gradient. So starting from that left point, I'm starting at negative 4, negative 2. And I'm going up first of all. So I went from negative 2 up to 1. So my rise equals 3. And now that I'm here, I'm at negative 4. And I went across 2. So my run, I went from negative 4 to negative 2. So my run is 2. So therefore my gradient equals 3 over 2, which is rise over run. And the other things I'll pick out, how about, like, when we're using this formula, I need a point. So in this case, I can actually use either point. It doesn't matter which point you use. I'm going to just use this point, just because it's got smaller numbers. There's actually no difference at all. So here, I'm going to say that x1 equals negative 2, and y equals 1, because they are the coordinates of that point that I'm looking at. Okay, that one there. So that's negative 2, 1. And now, again, we're just going to put it into that formula. Again, the formula, I'll write it again. Y minus y1 equals mx minus x1. So if we were to substitute these numbers in, we'd have y minus 1 equals 3 over 2. X plus 2. You might think, well, why is it plus? Well, if we're looking at this, we have minus x1. So if we do minus negative 2, that becomes positive 2 again. So that's why it's become a plus 2. And then, again, like I said in that previous example, you could just leave it as that, because that is technically right. But how about we just get rid of that fraction again? So what we will do is let's just multiply everything 2 first of all, because I want to get rid of that denominator. We're going to have 2y minus 2 equals 3x plus 2. And then why not also expand the brackets? So if we were to expand the brackets, we'll get 2y minus 2 equals 3x plus 6. We can just leave it there. We could go one step further and move everything across the other side to make it in general form. So let's minus the 2y and let's plus the 2. So we have 0 equals 3x minus 2y plus 8. And now will probably be like a perfect answer that you can get there, because that's now in general form. Again, you don't really need to do that last little bit until you're in year 11 and year 12. But I just wanted to might as well show it out for the people that are thinking who can go a bit further. So those are just 2 examples. Just to recap, the three things you can pick up from today's lesson is first of all a formula: y minus y1 equals mx minus x1. Alright, that's the new formula, that's the point gradient formula that you use to find the equation of a line if you have a point and a gradient. And the two other things that you can pick up is there's two forms for a line. So we have y equals mx plus b, which is a fairly simple one. And then we also have 0 equals ax plus by plus c. And that's that general form that I was talking about. Again, you don't need to worry about it too much, but we're saying we have 0 on one side, something from the x, something from the y, and something else, and that's it. So these are this is the gradient intercept form, and this is the general form. Alright. Anyway, hopefully this video has been useful. And so if you're in the Year 9 class now, you're going to be spending the next 2 lessons working through a bunch of exercises. This video will be also going up onto Edmodo, so you can just watch it at any time as well. And you just need to watch it again. There it is. Hopefully it's been helpful, and I will see you in the next few days.